David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember that you can slow down or speed up the playback if that helps you follow along. Second, you could turn on the captions and watch my words go by on the bottom of the screen. And last, you can pause the video at any time to catch up with your notes or think about the topic. Today's topic is understanding the measures of central tendency that we covered in the last lesson. Now, we did have 3 different measures. We had mean, median, and mode. And they tell you different things about the data. And also, when you look at the 3 together, you can talk about that data as well. So we're going to use a small data set right here in this example and bring out some of those ideas. So first off, here's our data set. Ages of 15 cats. I don't know about you, but I think the textbook authors liked cats for some reason. We keep getting examples with cats. So here are our ages. Now, to take a look at this data, I want you to go ahead and make a frequency table. This is just a list of all the ages. So go ahead and put that list into a frequency table first. Okay, let's see how you did. Here's my table. I have 2 cats that were 10, 3 that were 11, 4 that were 12, 2 that were 13, 2 that were 14, and then I had 1 heck of an old cat at 24 and 1 even older at 25 years old. I don't know about you, but I don't think I've ever met a 25-year-old cat, but I know that it does happen. Okay, now what I want you to do is go ahead and use your calculator and calculate the mean, the median, and the mode. Okay, so here's what I get. I get 13.6 for my mean, and my mode and my median are the same. They're 12. Remember, the mode is the one that occurs the most frequently, which is 12, 12, 12, 12, 12, right there. And the median is the value for which half the data is larger and half the data is smaller. So our median and our mode end up being the same. Now, there's something going on here with these 3 numbers. Pause the video and think about that. Okay? Let me ask that question differently. If you had to pick one number to describe this data set, which one would you pick? Okay, for me, I would either pick the median or the mode. They're the same, and they also represent this data most faithfully. Now, the mean is quite a bit larger than the median and the mode. Why would that be? Pause the video for a sec, take a look. Okay, if you said, well, of course it's larger because we have these 2 cats that grew to be quite old, 24 and 25. They're 10 or 11 years older than the next oldest cat that was 14 years old. So we call these data points outliers, and they skew our mean. They push the mean up to 13.6. Now, outliers kind of sound like, hey, they're way out there. And it's true, they are. And so with these 2 outliers in our data set, it skewed our mean higher than our median and our mode. So if I were describing this data set to you with just one number, I would say we sampled 15 cats and the median age was 12 years old, or the mode was 12 years old. I wouldn't use the mean because that's skewed by our outliers. Let's do one more example, and I'm going to ask you a few more questions along the way. So here we are. We've got monthly salaries of people working at a tire factory. So no more cats. People are working at a tire factory where they make tires for cars. Now, here are our salaries, $4,000, $4,200, $4,200, and so on. Now, I want you to take a look at that data and tell me if you see anything there that seems like it doesn't quite fit. Okay, now, if you noticed that all of these are between $4,000 and $4,600, except I have 2 monthly salaries that are like super high. Here's one that's $20,000. And here's one that's $42,000. So those pieces of data don't quite fit with the rest of the data that we have here. Now, I want to ask you a question. Do you think these are errors? Could someone have added a 0 to these numbers when they collected the data just by mistake? Maybe they just had a little spasm and wrote another 0. So pause the video and think about that for a minute. Okay. I think it's very possible that they could be an error. However, there's also a fairly likely explanation. Perhaps all of these people right here work on the factory floor. They run the machines and do all that kind of stuff. And then maybe this person might be the general manager of the entire plant. And this person might be the CEO of the company or maybe the owner of the company. So that kind of makes sense. The people at the top of a fairly large organization typically make quite a bit more than everybody else. So it could be. You always want to ask yourself questions like that, especially if you're dealing with raw data. For example, if you're measuring the ages of students at a high school and you have a 36 years old in your data, that could be a problem. Okay, so now what I want you to do is use your calculator and calculate the mean, median, and mode for this data. Okay, let's see how you did. Check it out. My mean, rounded to 3 sig figs, is 8,460, and my median and my mode are the same again. The middle value and the most frequently occurring value are both 4,400. Now, this example is fairly similar to our cat one. We have a mean that's quite a bit higher. It's more than twice as big as the median and the mode. And basically, that's due to these two outliers. So these two data points are skewing our mean quite a bit higher. So if you were to go report to your friend and say, yeah, I did some statistics on salaries at the auto or at the tire plant, and guess what? They have an average salary of $8,460 a month. I want to go work there. That's a lot of money. If that's the average salary, that's a bad decision, because that average salary is not reflective of what you're likely to make there. Because if you go get hired on, you're going to be in this zone. You're not going to be the general manager or the CEO or the owner of the company. You're going to be in this zone. And so if we did our stats on these numbers and excluded the outliers, that would be a better way to look at the central tendency of this data. So guess what? I want you to do this calc again, but I want you to take away the outliers and let's see what you got. Check this out. Now, without the outliers, the median or the mean is 4,360. The median is also 4,400, as is the mode. So now I'd be comfortable reporting the mean as a true reflection of what, say, somebody might get if they went to work for this tire company. We took the outliers out and we got some stats that kind of are more accurate for our picture. So if I were doing a survey of salaries at the factory, I might want to put some caveats on that before I start my study. I might decide I want to find out what the average salary, or run some statistics on the average salary of the standard workers at the factory, the people that actually do the making of the stuff, and exclude the highest level employees / owners of that factory. Okay, so in summary, outliers skew statistics. In this case, we had outliers that were unusually high compared to the rest of the data, and that pulled our mean up compared to the median and the mode. So identifying outliers is crucial to understanding which stats you're going to use when you talk about a data set. So we can use this data set. We don't have to exclude the outliers, but then we're going to focus on these two numbers. Alternatively, somebody may come to you with a statistical report and they're going to make the case. They're going to say, hey, check this out, man. You can earn a lot of money. If the mean at that company is 8,460, that's a great place to go. But if you're the discerning mathematician and you understand statistics, then you're going to look at that and go, but check it out. The median and the mode are 4,400. So these two numbers are way more descriptive of the data set and of the salary situation at that tire factory. Now that you've watched the video, jot down a couple notes so you can ask questions at our next class. Remember that you can also watch the video again just to deepen your understanding. Lastly, if you enjoyed the video, please click like and subscribe.